Hi everyone, Miss Gauss here. In chemistry, we need to be very specific and very precise with our measurements. Therefore, whenever we read equipment, we need to always estimate one more digit. Now, you might have done this before, but just in case, let's do a couple of examples so I can show you exactly what I mean. If we look at this first example of a graduated cylinder, we'll be measuring volume, and volume is measured in milliliters. If we look at the first long line, this is 50 milliliters. This is 60. So if we count the little increments, it'll be 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. In this example, each increment is in the units place. So therefore, we need to estimate the first decimal or the 10th position. So for this example, our meniscus sits right at 56 milliliters. We can tell with certainty that it's 56 milliliters because we are dealing with the units increments, but we need to estimate one more. So in this case, since the meniscus is right on that 56 milliliter line, it'll be 56.0 milliliters. This 6, that's the units place. We know that for a fact. So this is known based on the equipment we are using because we can see the actual line. Then we have to estimate one more spot. So this is the one we estimate. Okay. If we look at the next one, here we go from 3 to 4. So these increments do not go up in the units place. It goes up in tenths. So this would be 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, etc. up to 4. Then this would be 4.1, 4.2, 4.3, 4.4. All right, so now our meniscus lies somewhere between 4.3 and 4.4. Okay. Now we know for a fact, we can see the lines increasing, that correspond to the first decimal place. So therefore, we need to estimate one more spot. So we need to estimate the 100th or second decimal spot. So here we go. This would be 4.3. Do you guys see it's pretty much halfway between 4.3 and 4.4? So let's give it, how about 4.35 milliliters? Okay. So you're always going to estimate one more spot than what you can see on your equipment. All right. I want you guys to complete this side of the worksheet. And when you're done, move on to the triple beam and 4 beam balances. Let's go ahead and do an example here as well. All right, so on this first one, the top beam, that's your tens. These are your hundreds. These are your units. But you see that your units are separated into tenths or the first decimal. Okay. Therefore, our answer will have a number in the 100th spot. And the number in the 100th spot or the second decimal place, that's the one we will be estimating. So let's read this one. This is going to be 622.123456789. Okay, so we can definitely tell it's 622.9, but we need to estimate one more spot. Now, that little arrow, if you guys look carefully on your worksheet, you'll see it, is exactly on the 0.9. So the next spot that we estimate, I'll estimate as 0. Okay, and since we measure grams, it'll be G, grams. Okay, let's look at one more. Here, this will be 153. Okay, there's our mark. 153.1234567. So this is definite, 153.7. But since we can definitely read this first decimal, we need to go ahead and estimate the next one, which would be the hundredths. Again, that arrow is directly or exactly on that 0.7 line. So therefore, we add a 0. Okay. Go ahead and try the rest. I also want to show you guys the back, the reading thermometers part. Okay. Let's look at this middle one because my ink came through from the other side. Here we go. Okay. Here, we are starting at 0 and going backwards because we're in the negatives. So here, this first line will be -1, -2, then -3, -4, -5. Okay, so we are reading the units place. So if we are reading the units place, then we need to estimate the next digit, which would be the tenths or the first decimal spot. Okay, so let's go ahead and estimate, or read our number first and then estimate. So this line is -1, this one is -2, this one is -3. Now, as you guys can see, the meniscus is not quite at -3. So it's going to be -2 point something. Okay, so -2. It's not quite halfway between -2 and -3 either, so it's not 0.5. It's closer to -3. So I'm going to estimate -2.7. And let's assume this is degrees Celsius. Okay. Now this last estimated digit, not all of you are going to estimate the exact same number. So therefore I will accept a range. So for example, in this diagram, I would accept -2.7, -2.8, or around, maybe -2.9 degrees Celsius even. Okay, complete all of these. And then I also want you to complete this table. Okay. This table, I only want you to worry about converting from degrees Celsius to Kelvin. The table, or this little chart up here, shows you that to go from Kelvin to degrees Celsius, you have to subtract 273. And to go from degrees Celsius to Kelvin, you need to add 273. Kelvin is always going to be the larger number. Always going to be the larger number. Okay? So just a quick example. Let's say you have 20 degrees Celsius. How much is that in Kelvin? Okay, so to go from degrees Celsius to Kelvin, you add 273. So 200 plus 273 is going to be 293. So that equals 293 Kelvin. Okay, so 20 degrees Celsius equals 293 Kelvin.